Welcome back to the deep dive. You know that feeling, right? You're deep in some complex project, maybe juggling tasks, working with a team, and suddenly you kind of realize, wait, have I lost the plot on this one part? Or maybe it's a huge project, months long, and keeping everything aligned feels like, well, herding digital cats. It's a huge challenge. Information overload, keeping context straight. Well, today, we're going to dig into how some really advanced AI systems are being designed to tackle exactly that. Our topic is meta-temporal coordination in AI systems. Sounds a bit technical, maybe.
Just a bit.
But we're going to explore how these AIs keep a consistent understanding of their own work over time, even when tasks change, new info comes in. You get the idea. We've got some fascinating excerpts here from a document on this very topic, and our mission, like always, is to pull out the key stuff for you, the real nuggets.
Yeah, and it's crucial stuff because this meta-temporal coordination, it's not just some side feature. The source material calls it one of the core coordination modes.
Coordination modes, like different ways the AI collaborates.
Exactly. Think of it like how human teams have meetings, shared docs, quick chats, right? These are different loads. Well, AI systems, these advanced ones, have their own specific modes. And this one, meta-temporal coordination, it's all about holding on to that historical thread, making sure context doesn't get lost.
Okay, let's unpack that a bit. Context continuity. What are we really talking about here in an AI system? What's the goal?
Right. So at its heart, meta-temporal coordination is about the meta-AI's job.
The meta AI. The boss AI, sort of.
You could say that, yeah. The overseer, the orchestrator, managing all the other AI agents. Its specific role here is maintaining that continuity across different versions, different iterations of a task or project. The main goal, simple, really, make sure context sticks around through everything the system does as it evolves.
So it's like the system's perfect memory.
Kind of, but more active. It's not just storing stuff. It ensures perfect fidelity, Every decision, every output, every lesson learned, it's all retained, perfectly callable, which allows for a level of consistency we just don't see in human projects.
That perfect fidelity part.
Right.
That's a big difference. Okay, so if it's that critical, how? How does this meta AI actually pull this off? The sources mentioned two key pieces, right?
They do. Two main mechanisms.
Let's start with the first one, the prompt context mechanism. We usually think of prompts as just the start, the instruction. But this sounds different, like continuous refinement. How does that maintain continuity?
Yeah, it's not just about the initial prompt. It's about constant iterative refinement, precision tuning, really. And the source material highlights a specific AI agent for this called Lyra, the prompt architect.
Lyra, the prompt architect. Okay.
So Lyra's job is optimizing prompts, structuring workflows, making everything super clear. But here's the kicker. Lyra doesn't do this in a vacuum. Lyra refines prompts based on what other AIs are producing, like, say, Aurora working on design patterns or Codex generating code.
Ah, so it's reactive. It sees the output and sharpens the instructions.
Exactly. And as Lyra sharpens those prompts, the meta AI, the overseer, adjust who does what next. It's this constant loop. Refine prompts, the output, adjust tasks, refine again. It ensures the instructions evolve perfectly with the project. Keeps everyone, well, every AI on the same page. No lost threads.
Okay, that makes sense. If the instructions themselves are always evolving accurately, the context travels with them. But what about everything else? The actual designs Aurora makes, the code from Codex, human feedback, that's not all in the prompt, right?
Good point. And that's where the second component comes in. They call it the knowledge graph.
Knowledge graph. My first thought was, okay, that's the system's collective memory. Is that about right?
That's a perfect way to put it. It really is. It's this central dynamic graph. The meta AI maintains it, and it pulls together everything. Insights from humans, data from all the AIs. It becomes the system's institutional memory, the single source of truth.
Okay, single source of truth. I like that. But can you give us some concrete examples? What kind of stuff actually goes into this collective memory?
Well, it's pretty comprehensive. The sources mention things like optimized design patterns, maybe from Aurora, code snippets from Codex. Makes sense. Also, a standardized vocabulary for prompts, probably curated by Lyra, to keep things consistent. And, really important, the full history of feedback from human agents. They mention one called Dennis, for instance. And in the specific system, they talk about this Etheria OS.
Right, the bigger framework.
Yeah, this knowledge graph function has its own component name, the concordium.
Concordium, okay.
And it stores definitions, learned heuristics, Those complex rules of thumb the system figures out over time.
Ah, the wisdom it gains.
Exactly. And the system chronicles like a full operational log. It's
Yeah.
not just data, it's the system's entire experience, its accumulated knowledge.
Wow. Okay. So we've got the what maintaining context and the how evolving prompts via Lyra and this massive knowledge graph, the Concordium. Let's bring it back to the listener. Why should you care about this? What does meta-temporal coordination really mean for how these AIs work and develop? Why is it so critical?
Well, at the end of the day, it's about reliable evolution. This coordination ensures that as tasks change, as things get iterated on, the system never loses sight of why decisions were made, what was learned before, or the main goal. This is absolutely fundamental for the system to continuously improve itself, to adapt without forgetting.
Like avoiding that problem where a new team comes onto a human project and kind of starts over, losing old knowledge.
Precisely that. Imagine a project running for years.
Yeah.
With this, the AI doesn't suffer from knowledge decay. The meta-AI, they call it kick la meta internally, apparently.
Kick la meta. Got it.
Right. It orchestrates everything, assigns tasks, manages roles, and crucially, keeps that knowledge graph pristine, preserving that shared context. It allows for a scale and consistency in long-term projects that's just, well, it's beyond what humans can typically manage without massive overhead and potential for error. It unlocked the ability to build truly huge, interconnected, evolving solutions.
It really is pretty amazing when you lay it out. Meta-temporal coordination. It's essentially how these advanced AIs get a perfect, persistent memory of their own work, ensuring nothing gets lost, keeping things efficient through those refined prompts and that giant knowledge graph, like never forgetting a single detail, no matter how long or complex things get.
Which definitely leads to a final thought, maybe something for you to chew on. If AI systems can achieve this kind of perfect context continuity, storing every single lesson, every decision with total fidelity, what does that imply about their ability to evolve and adapt, especially compared to us humans, where our complex projects rely on, let's be honest, imperfect memory, scattered information, and changing teams? Is a perfectly remembered past always the best foundation for future adaptability? Or could there be downsides too?
That is a deep question to ponder. Does perfect memory make you more or less flexible? Well, we hope this deep dive into meta-temporal coordination gave you some new things to think about, some surprising insights maybe. Keep exploring this incredible world of AI coordination. We'll catch you on the next one.